So this is problem 21 of chapter 17 of Giancoli 6th edition. And what we have is the following. We have two identical point charges. So we have these two identical point charges. I'll call one Q1 and the other one Q2, but we know that they are identical. Both have the same charge, 9.5 microcoulombs. Okay, and they are initially a certain distance away, so I'll put here Q1 and I'll put here Q2. So the distance between them is given to us is 3.5 centimeters. So the distance that they have is this 3.5 multiplied by 10 to minus 2, this is in meters. And we want to know if they are released, because for them to be there, since they are identical, we are holding them. They want to fly apart. So for them to be there, we nail them, we are holding them there, and we want to know if they are finally released at the same instant, both at the same instant from rest, how fast will each be moving when they are very far away from each other. And they give us one more information. They say that the masses of these particles, remember, they are identical. The mass is 1 milligram. So I can also say that it's 10 to minus 3 grams and 10 to minus 6 kilograms. So let's put it directly in kilograms. So 10 to minus 6 kilograms. Very well. So how are we going to get speed here? They just give us charge and distances and masses. Well, the idea is, initially, these two particles that are being nailed there, those two particles create a system with a lot of potential energy. Meaning, if we let them go, they will move. So there is a lot of potential energy. And what is this initial potential energy? It's very similar to the problem that we solved before, the problem 18. Now the potential energy is the charge of one of the particles and the potential created by the other. And so it's going to be K Q1 over R. So this is the potential created by Q1 multiplied by Q2. So this is the equation for the potential energy. Okay, so this is what we have initial. That's the initial energy, this potential energy. Now, if we let these two particles, if we release these two particles, we know they are going to move. So the system will lose this potential energy. And where is this potential energy going to go? To kinetic energy. Okay, so this potential energy that I wrote here is the initial total energy of my system. The energy is conserved, so this initial energy will have to be equal to the final energy. And what is this final energy where these particles are very far away? When they are very far away, there is no potential energy anymore. There will be only kinetic energy. Kinetic energy for particle 1 and kinetic energy for particle 2. Okay, so I'm going to put here, this will be equal to the kinetic energy of particle 1 plus the kinetic energy of particle 2. What is the kinetic energy of particle 1 and of particle 2? Okay, so for particle 1 is 1/2 of m of the particle 1 and the v1 of particle 1 square, and for particle 2 is 1/2 of m2, the mass of the particle 2, speed 2, now the speed of particle 2. Okay, so let me put all this together. What we have is the value that you got for this potential energy. Okay, so you have to compute that, K, Q1, Q2 divided by R, so this number you have. And on the right side, you have these two kinetic energies. But remember, these particles are identical. So they have the same masses, they have the same charge. So of course, how I'm going to write these two kinetic energies as a single one. 1/2 plus 1/2 is 1. So then I have here the mass of the particle, V square. Okay, the masses are the same, so I just sum these two halves. And now from here you can get the speed. You have all the information. you have K, Q1, Q2, R, the mass is given, and from here you can now get the speed of these particles. Each one will have, they will be moving in opposite directions, but with the same value, with the same speed.